Diseases spread by mosquitoes kill about 1 million people every year. Team ELMO fights malaria infections with two-part solution. Please welcome Seppo Meri.
So, ladies and gentlemen, this is Team ELMO. So, our project is dealing with a similar question that you heard before, but this is related to the whole world. So, actually, what is the deadliest animal in the world, and what are the problems that it is causing? So first, let's ask, what is this animal? So I can't see you, but maybe you could guess it's tick. Ticks are dangerous, but there are other dangerous animals as well. So the most dangerous one is not a lion, it's not a snake, it's not even a wolf, although one wolf was biting somebody's hand yesterday in the zoo, a child. No, the most dangerous animal in the world by far is mosquito. So mosquitoes are transmitting diseases like malaria, dengue, yellow fever, chikungunya, Zika virus, and kill more than 700,000 people a year. They kill more than humans kill in wars and other conflicts. Malaria is the most important one of these diseases. So every year, more than 200 million people get infected by malaria parasites, and almost 500,000 people die because of malaria. And they are mostly children in Africa. So ELMO stands for Elimination of Mosquito-Borne Diseases. So we want to devise ways how to block the transmission cycle of many of these diseases by directly targeting the mosquitoes themselves. And we have two main projects there. One is to develop a vaccine against mosquitoes, and another one, mosquito nets that will act as traps for mosquitoes. And I will talk about the latter project now. So the story started in Africa, in Congo, where we have our colleague Mikko Aalto, who is a surgeon. So he has been working there for 18 years, and every evening when he goes to bed in his house, he saw that there are lots of mosquitoes flying against the windows of his house and all other houses. And then the same procedure occurs every day, every evening. So he was thinking, would it be possible to actually catch those mosquitoes that are trying to get inside the houses where the humans sleep inside and act as bait for the mosquitoes? And Ayman Khattab in my lab in Helsinki has doing a lot of this practical work to realize this project. So Mikko came up with an idea. Would it be possible to design a net that lets the mosquitoes to fly to one direction but not back? And when you have two of these nets against each other, or one transmissible net and another one that is not, then you could actually catch the mosquitoes in between these nets. And with these nets, you would not actually need any insecticides. They would only act as traps. And we started planning this together with the Tampere University of Technology. There are engineers, so they helped in synthesizing the nets by three-dimensional printing, for example. We had about 30 different types of prototypes for nets, and we tested them in a tunnel in our laboratory. And we put mosquitoes, which we are growing in the lab, at the other end of the tunnel, as you see. And then we needed to have a bait to attract the mosquitoes. And then we did some research what would be the best bait. And at the end, we found that it's the used human socks that are acting as the best baits for mosquitoes. So there's no chemical, carbon monoxide or dioxide or anything that is better than this. And of course, we play a lot of football. We have a continuous supply of these socks. So that's very handy and practical. And with the best prototype net that we had, we would actually have 90% of the mosquitoes to go into the trap, and nobody came out. So it was very efficient working in the lab conditions. And we had one or two prototypes that worked like this. So then we went to the field conditions. We have collaboration with Tanzania. There's a research area in the northern parts in Muheza where there are these kind of test huts where you can do this kind of experiments. So we put these nets into the windows there and recruited local people to sleep there as baits. And we got very good results so that these nets actually were able to trap mosquitoes also under field conditions. So this is, we think, a rather clever and intelligent solution for this, because the nets only are based on physics. There's no need for insecticides. We don't need any separate energy sources to create any substances there. And we don't need any artificial baits. It's us humans that act as baits. And furthermore, we can produce these at relatively low cost. So this is a collaboration together with the Tampere University of Technology and Aalto University, whose role is to analyze the implementation of this concept into the field conditions, mostly in Africa at this point. Then we have a number of companies like the Lindemann Group, who is already producing nets. They are fishing nets. It's the biggest producer of fishing nets in Finland, I guess, at the moment. And then there are companies who are producing molds and other things that we need in the production of nets. We are also having architects and people who actually build houses in Africa to start the design already from the very beginning. So what we want to have more is to enlarge this and have a large industry support to produce these nets in a large scale. We need more people to do some field work, at least to sleep in the huts there as baits, if nothing else. We need also skilled people to work in the lab with the mosquitoes, because we can use them also for our studies and study whether there is a malaria inside a parasite or inside a parasite inside the mosquito or not. WHO requests us a 4-step procedure before they can accept the protocol, and for implementation, we've done the lab tests, we have started the field tests. Next, we need to show that there's real impact in the field to reduce malaria in the local area. So what else is needed? Of course, if anybody has a big warm heart, so they can also contact us. Thank you very much.